Hello everyone. Today we are going to look into Gini Index. Gini Index mainly helps us to measure the impurity of a node. So in a decision tree that we have discussed in our last session, we have seen that we need to compute Gini Index in order to determine which attributes or which conditions should be used at the node. So it helps to determine the best split while building the decision tree. So let's look into the example that we had discussed earlier when we were discussing about decision tree. There we observed that salary attribute was chosen by the decision tree as the root node, the node at which the decision tree begins. So salary greater than 10K was the condition that was being validated at the root node. So how the decision tree is able to take such decision that this condition should be taken, why salary attribute is only chosen. So this is where the Gini index will come into picture, and we are going to look into detail how the Gini index is computed. Let's look into the formula to compute the Gini index. What does our formula say is it is calculated by subtracting sum of squared probabilities of each class from 1. So when you apply this formula, what do you get is the Gini impurity at each node. This will help to determine whether it is a best split or not while building a decision tree. Let's look into this. Suppose we have data set D, okay, and we have partitioned this data set on attribute A. It divides our data into two halves, D1 and D2. Now what we have to do is, in order to compute the Gini split index, is we have to compute the Gini impurity for D1 and impurity for D2, multiply it by the weight. Weight is the probability or the relative frequency over here, which is D1 divided by D, okay, multiplied with the Gini index for D1 plus D2 divided by D is the frequency, relative frequency, the probability over here, multiply the Gini index of D2, and then we have to add this up. This will give you the total Gini index. Let's consider a new data set this time. We have customer ID, loan amount, marital status, and loan status. Loan status is something that we'll be predicting with the help of decision tree. And for prediction, we'll be using attributes either loan amount or marital status, which are the independent variables. So which attribute should be chosen at the root node? What conditions should be applied? So for that, Gini index will be used. So consider we have condition at our root node as loan amount greater than equal to 250K. For this condition, we have to first check how many records satisfy this condition. How many records are true for this? We have two records, right? Customer ID 3 and 5 have loan amount 250 and 1000K respectively, hence which is greater than equal to 250K, hence it will come under this category true. So the probability of 2 is 2 out of 5, right? Similarly, for false, the probability will be the remaining records which do not satisfy this condition. There are remaining 3 records out of 5, hence the probability of false is 3 out of 5. Let's proceed to derive the Gini impurity at each node. Let's first focus on left hand side where the condition is true. We have two records. What is the formula to derive the Gini impurity at this node? It will be 1 minus sum of squared probabilities of each class. So what are the two classes here? We have good and bad. So first let's look into probability for good. So out of 2, how many records do we have? 0 records. Plus for bad, we have 2 records. Okay. So this comes out to be 1 minus 0 plus 1, which is equal to 0. So the Gini impurity at this node is 0. Why? Because both the records over here are falling under the same category or classification. We do not have mixed data set. Hence, it is a pure node. Similarly, let's compute the Gini impurity at the other node where the condition is false. The probability here is 3 out of 5. We have 3 records out of 5 which satisfy this condition. And out of these three records, we have one which falls under the bad classification and the other two under the good classification. Okay. So how do you compute the Gini impurity? 1 minus sum of squared probability of each class. First, let's look into the class good classification. So out of three records, how many are in good? 2. And for bad, 1 out of 3. So what do we get? 1 minus 4 upon 9 plus 1 upon 9, which is equal to 1 minus 5 by 9, which is equal to 4 upon 9. Let's calculate the total Gini index now. What does our formula says? We have to compute the Gini index of the individual node and then multiply with the weight, which is the probability, and then sum it up. So let's do this. What is the probability here is 2 upon 5 multiplied with the Gini index, which was 0, plus what was the probability over here? 3 upon 5. Gini index was 4 upon 9, which comes out to be 0 plus 0.14, which is 0.14. This is the total Gini index. Lower the Gini index, it's better. To understand this more clearly, let's take one more example. I haven't taken any data set here, but assume that we have a data set with just 4 records and we apply a condition on loan amount in such a way that it splits the data equally, as in we get all the good on one side and bad on other side. Okay, so the condition is loan amount greater than equal to some xx amount. With this condition, out of the 4 records, 2 records come on left hand side for true, and out of these two, all the records are bad. Here on false, we have 2 records out of 4 which come which satisfy this condition and come on the right hand side, and out of these 2 records all are good. So these two are the pure nodes. Now, as we have done before, applying the Gini index, we have to take sum of squared probabilities. So probability of this of good plus probability of bad, the whole square, and we add this. So here we get 0 and here we get 1. So the probability or the Gini index, sorry, comes out to be 0 over here. Okay, why the Gini index is coming out to be 0? Because it is a pure node. Whenever it is a pure node, the Gini index will come out to be 0. Now, similarly, if we compute the Gini index here, what it is going to be? Sum of squared probabilities for good, 2 out of 2, and for bad it will be 0 out of 2, the whole square. When we add this, we get 0. What we have to do now, as we have done earlier, we have to take the weight, multiply the probability with the Gini index and add it. As we have seen, like both our nodes are pure nodes, hence the Gini index is 0, which is the best scenario. Let's take another similar example. Now we have loan amount which is greater than equal to y some condition. Now this condition is again dividing the 4 records into 2 different halves. For the 2 records which satisfy the condition come over here, and 2 which do not satisfy this condition landed over here. Now out of these 2 we have 1 bad and 1 good. Similarly on right hand side we have 1 bad and 1 good. So the Gini index on left hand side, first look into the left hand side, we have what is the probability of good is 1 upon 2 the whole square, bad is 1 upon 2 the whole square, which comes out to be 0.25 plus 0.25, and the Gini index here for this node comes out to be 0.5. Similarly, we are going to get 0.5 for this side as well. The total Gini index is going to be we are going to multiply the probability here, right? 2 upon 4 multiplied by 0.5, which is 0.25. So even on this side, you're going to get 0.25. When you add this, the total Gini index comes out to be 0.25, which is not a good scenario because you're splitting in such a way that you are not getting a pure node anywhere, and it is a mixed. You are getting 50-50 probability of the record falling under good category or bad category, right? Now let's take one more example. At our root node, we have condition loan amount greater than equal to ZZ, some arbitrary amount. The condition is such that all the records in the dataset satisfy this condition, and there are no records which do not satisfy this condition. So the probability for true comes out to be 1, 4 out of 4. Considering we have 4 records, and the probability of no is 0. Now we have to look out of 4 how many are good and how many are bad category. So we have 2 which comes under the good category and 2 records which come under the bad category. Okay. How are we going to compute the Gini index? In the similar way, probability of good plus probability of bad the whole square. What is probability of good? 2 out of 4. That is half. Bad again same, 2 out of 4. Hence we get 0.25 plus 0.25, which is 0.5. When we subtract it from 1, we get 0.5. On here, on this side, the probability is 0. Hence the Gini index over here comes out to be 1. Gini index over here comes out to be 0.5. Now to compute the total Gini index, what we have to do, as we have done earlier, we have to multiply the Gini index on each side with the probability for true and here with the probability of false. And then we have to add. So the total Gini index comes out to be 0.5, which is again not a good case scenario. Just a recap on the scenarios that we have worked upon. Consider we have a data set where there are two types of classification, good and bad. Each data element is either classified as good or bad. Our split criteria is such that the data set is divided into two subsets based on the condition which is applied on an attribute in such a way that it totally segregates the values. All good will come on one side and all bad will go on the other side. In this case, our Gini index will come out to be 0. Now to the same data set, if we apply a condition or a split criteria in such a way that both ends we get mixed data elements, both and we have elements in such a way that they have 50-50% probability. In this case, the Gini index will come out to be 0.5. And last scenario what we have seen is when the data on a data set we apply a condition in such a way that all the data set again comes out to be the subset. Okay, and again they have the same probability, equal probability. Then in this case as well, the Gini index will come out to be 0.5. Hope you have understood the concept of Gini index, how to compute this, how it is calculated. In next session, we'll look into entropy and information gain. Thank you.